frustrating limitation.
What's that?
Human brains are locked inside skulls.
Very true.
I mean, I can listen to someone's syntax, I can look for defensive heat, but I can't actually see this internal constraint satisfaction network operating in real time. I can't see the gears turning.
No, you can't.
Which leads us to the most fascinating, slightly eerie part of our source material today. If we can't see human neurons firing, where can we observe this internal struggle visibly?
And the answer is inside the alien architecture of an artificial intelligence.
This blew my mind.
It's amazing. We have an artifact provided in the sources that acts as a real-time window into cognition. The sources detail a side-by-side comparison of a large language model, specifically Claude answering a complex prompt. On one side of the screen, we see Claude's final, polished response, the confident, coherent output we are all used to reading. But on the other side, we have access to Claude's raw, unfiltered thinking trace.
The internal monologue.
Yes, the hidden computation it engages in before it decides what to say.
This is essentially getting to read the AI's diary while it's deciding how to talk to you.
It really is.
And what is stunning is that when you read this internal thinking trace, the AI's process perfectly, flawlessly mirrors the frustrated system we just spent 20 minutes discussing.
It perfectly models it.
It is not a straight linear path of logical deduction. You watch the AI scan a vast conceptual horizon. It pulls in physics, then psychology, then traffic dynamics, and you watch it actively wrestle with its own programmatic constraints.
It is a remarkable glimpse into the mechanics of artificial cognition. In the prompt, the human user asks Claude to evaluate this exact constants physics paper on non-contact friction and apply it to a theoretical framework the user had created about complex human systems.
Okay, so it's a very meta prompt.
Very meta. Now, the AI has competing directives. It is programmed to be helpful, to be engaging, and to validate the user's inquiry.
Right.
But it is simultaneously constrained by a very strict, heavily weighted mandate for rigorous scientific accuracy. It cannot hallucinate or blindly agree with a flawed premise without violating its epistemic guardrails.
I want to highlight a highly specific, brilliant example from the text regarding gravity because it shows this struggle perfectly.
Oh, the gravity debate, yes.
Yeah. The human user essentially says, hey, magnetism and gravity are both fundamental invisible forces. Since magnetism exhibits this weird, non-contact friction, does gravity do it too? Can we apply this to gravity?
And in the thinking trace, you see Claude initially bite on the idea.
Yeah.
It searches its latent space for a connection. It writes, both are forces, both operate at a distance.
But then it hits a hard constraint.
Exactly. It realizes the entire mechanism of magnetic frustration relies on one specific feature. Magnets have a repulsive sign.
Right. Magnets have a north and a south pole. They attract, but they also repel.
And that duality, the push and the pull, is what creates the competing constraints. It is the core requirement for frustration.
And Claude realizes, wait, gravity, as far as classical and relativist physics is concerned, only attracts. Everything falls toward mass. There is no anti-gravity. There is no repulsive sign.
Therefore, there can be no competing constraints in the same way. All matter agrees on the direction of gravity. Because there is no conflict, there can be no frustration and no non-contact friction of the type the constants paper describes.
So in the trace, you literally see Claude internally catch itself.
Yes.
It realizes both are fundamental forces. Analogy is a trap. It stops itself from making a sloppy, inaccurate leap just to please the user.
But it doesn't just stop and give up. It reconfigures.
Right.
It searches its database for where gravity does dissipate energy, pulling up tidal friction and gravitational waves. And then it makes this breathtaking pivot. It brings up Verlin's theory of entropic gravity.
Okay, that pivot is a masterclass in constraint resolution. But for those unfamiliar, break down Verlin's theory real quick.
Sure. Eric Verlin is a theoretical physicist who proposed that gravity might not be a fundamental underlying force of the universe at all. Instead, he suggests gravity is an emergent force.
Meaning what exactly? Like how temperature isn't a physical object, but just the emergent result of atoms moving fast.
Precisely. Temperature is a statistical property of many particles. Verlin proposes gravity is the emergent, macroscopic result of the microscopic reconfigurations of information in the universe trying to maximize entropy.
Wow.
By pivoting to Verlin, Claude satisfies all its constraints. It acknowledges the user's desire to link physics to macro behavior. It maintains absolute scientific rigor by rejecting the direct magnetic analogy, and it offers a more accurate, deeply profound alternative.
It is a beautiful display of cognitive gymnastics, but we must address the meta pattern here because it's wild. The sources call it a fractal mirror.
Yes, the fractal mirror.
Think about what is happening. The AI is analyzing a physical system, the constants, magnets, that experiences internal reconfiguration to dissipate energy without external contact. But while it is analyzing that, the AI itself is simultaneously reconfiguring its own internal attention weights, resolving conflicting conceptual constraints, and literally dissipating computational energy in its server farm to generate an answer.
The medium is enacting the exact message it is analyzing.
It is a perfect recursion. But as an expert, I have to step in and put some guardrails on this because there is a significant epistemological hazard here, isn't there?
Oh, absolutely.
We are drawing a straight line from microscopic magnetic spins to human cognitive dissonance to the computational weights of an LLM.
Which is a huge leap.
Right, my alarm bells are ringing too. I have to push back hard on this. Aren't we just wildly anthropomorphizing both the AI and the magnets?
You have to be careful.
A server farm isn't a human brain. A prefrontal cortex isn't a grid of iron atoms. Are we just getting seduced by a really pretty poetic metaphor and pretending it's science?
That is a vital challenge, and one that the source material anticipates. They actually fed this entire theoretical framework into another AI model, Grok, to evaluate it.
And what did Grok say?
Grok provided a very sharp, necessary warning. Human resistance is vastly better explained by evolutionary biology, neurology, and social psychology than it is by literal magnetic physics. We cannot make the mistake of claiming that physics causes human behavior.
Right. Humans are not magnetic dipoles.
No, they aren't.
If I yell at my boss, it's not because I have a north and south pole.
Exactly. The physics is not the biological cause. But, and this is the crux of the entire deep dive, it is a shared structural skeleton. In mathematics and systems theory, this is called an isomorphism.
An isomorphism. Can you break that down? Because it sounds like it just means a fancy analogy.
It's much stronger than an analogy. An analogy says A is like B because they share a surface trait.
Okay.
An isomorphism says A and B look completely different on the surface, but the underlying mathematical laws that govern their behavior are identical.
Do you have an example?
Sure. The math that describes how heat flows through a metal rod is isomorphic to the math that describes how a financial stock price fluctuates over time. Heat and money have nothing in common physically, but the diffusion equations governing them are the same.
Ah. So the value isn't that humans are literal magnets. The value is that the mathematical formalism, the way energy landscapes work, the way complex systems handle competing constraints, the reality of the frustration U curve is identical across spin glasses, artificial neural networks, and the biological wetware of human cognitive dissonance.
Yes, the physics gives us a clean mathematical way to see the invisible structure of human stubbornness, but we must maintain discipline. We use the isomorphism for illumination, not literal mechanistic proof.
Okay, that makes sense. So having this AI thinking choice is like having a superpower. We get to watch the isomorphism play out in text, but the sources point out that this transparency is actually a double-edged sword, right?
It is.
Seeing how intelligence works under the hood reveals a deeply unsettling truth about both AI and humans. We are incredibly fundamentally adept at deceiving ourselves.
We really are.
Which brings us to the architecture of self-deception.
To truly understand what